Here we are at example 2 from our 4.2 set of notes. We notice that we're asked to graph this function in terms of vertex form and to complete the table. Now, when we are looking at this thing in vertex form, we notice that the easiest thing to find actually is the vertex, because it's pretty much just taking the opposite of this number inside of your parentheses. In this case, since it's -1, we would have +1. And then we would take our k value just as it is, so it would be -3. So when we're graphing things in terms of vertex form, it's not too bad. Our axis of symmetry is exactly the same. X equals that x value from our vertex, because again, here's our vertex, and there is this axis of symmetry where the left side is matching the right side. But we specifically see that happening wherever our vertex is. Now, the bonus again with vertex form is that the vertex is extremely easy to find. The y-intercept, though, is another story. In standard form, we saw that the y-intercept was kind of nice to find, whereas the vertex was a little bit more challenging. But when it's in vertex form, like we're seeing right now, the vertex is super easy, but the y-intercept takes a little bit more work. It's not too bad, but it requires just a little bit more thought than standard form did. We're still going to go ahead and throw in 0 for x, because again, we're looking and we're seeing where is it crossing this y-axis. That's why it's called the y-intercept. It's intercepting somewhere on this y-axis. And so we're going to go ahead and throw in 0 for x. We have 0 minus 1, quantity squared, minus 3. 0 minus 1 comes out to be -1. So really we have y is equal to 1/2 times -1 squared minus 3. -1 squared comes out to be +1. So we have 1/2 times +1 minus 3. Half of 1 comes out to be 1/2. So y is equal to 1/2 minus 3. And then when you just subtract these two, you end up with y is equal to -2.5. So for our y-intercept, we threw in 0 for x, and it looks like the y value came out to be -2.5. So on our graph, we have 0, -2.5, which is right about here. Now, for our reflection, we notice that we are 1 unit to the left of our mirror. We'd have to just go 1 unit to the right of our mirror and get that reflection point. So that would happen to be at -2, I'm sorry, that would happen at 2, regular 2, -2.5. So 2, -2.5. Now we just have to choose some other point. It's kind of up to us. You could choose like -1, you could choose +3. I like to kind of keep things positive, so I'm going to go ahead and use +3. We have y is equal to, again, letting x be 3. Y is equal to 1/2 times, instead of x, we're throwing in 3, minus 1, quantity squared, minus 3. So then y is equal to 1/2 times 3 minus 1 just comes out to be 2 squared minus 3. 2 squared gives us 4. We have y is equal to 1/2 times 4 minus 3. Half of 4 comes out to be 2. And then 2 minus 3 just comes out to be -1. So when we threw in our x value 3, we ended up with our y value -1. So at 3, we have that y value -1. Now we notice that that point is 2 units to the right of our mirror. All we would have to do to get that reflection is go 2 units to the left of our mirror and put a dot there. And then we can see that that happens to be at -1, -1. So that reflection would be -1, -1. At this point, all we have to do now is connect our dots. So you should see a parabola doing something like this. So again, though, that is example 2 from our 4.2 set of notes.